Previously I discussed the blueprint pure and the blueprint callable specifiers, which basically allow us to specify the blueprint accessibility of our functions, but we can also specify the implementation location by using these specifiers here, blueprint implementable event and blueprint native event. By default we implement our functions in C++, but we don't have to do that. We can declare the function in C++, but define that or implement that in blueprints. For that we can specify blueprint implementable event, and then the function can be implemented in blueprints. Our blueprint classes derive from our C++ classes, right? So basically we will override the functions that we specify as blueprint implementable event. We will override those in blueprints. Then we also have blueprint native event. If we specify that, the function can be overridden by a blueprint, but also as a default implementation in C++. The C++ implementation code should be written within a function with the implementation suffix. So in other words, where you define your function, you will have the function name followed by the underscore implementation suffix. The implementation function is called if no blueprint override is found. I have an example function, a native example, and we can see in the definition we have native example underscore implementation, because that is a blueprint native event. So basically when we compile, the engine will generate code for that function that has the underscore implementation. To begin, let's specify this getHitPoints as blueprint implementable event. Since it is a blueprint implementable event, we need to implement the function in blueprints. We will get a fail if we build now. Multiply defined symbols found. So in the dummy actor source file I will comment out the definition. Again, we are going to define that in blueprints. We are going to override that in blueprints basically. I will build and run, and this should now build fine. Now in the blueprint editor with the dummy actor blueprint open, we can go into the function section here and click on override. Then you can select getHitPoints, or you can actually type and search for that. By default it calls the parent function. I will delete that, get the hitpoints, and hook that up to the return node. Compile and save. I still have this logic in the event graph. We print out the hitpoints, then we set the hitpoints and we print it out a second time. Of course we don't have to go back to the level editor each time we want to simulate or play. We can just use this menu right here. Just some bad habits I have. We should always try to reduce the amount of clicks. Those add up over time. I will play in a new editor window, and this prints out 100 and then 50. If you should close off a tab for a function such as getHitPoints in this example, you can always open that up again by navigating to the function section in the My Blueprint tab and simply double click on the function that you want to inspect. Back in Visual Studio, let's specify setHitPoints as blueprint native event. Now in the source file we need to provide the underscore implementation suffix in the definition of setHitPoints. Save those changes, recompile. If I play, the function still works as we would expect. Something else that I'd like to demonstrate is that if we now override the setHitPoints function, we actually get this event node, event setHitPoints. We can change this to a function, as I'll demonstrate later, but for now let's implement this for an exercise. I want to use the getters and setters that are provided by default, as opposed to my own setHitPoints, otherwise we'll get some recursion, so I want to avoid that. However, if I attempt to set the hitpoints, notice that set is grayed out. We can get, but we do not have access to that setter. For an exercise, attempt to solve this problem by yourself, or at least think about what is going on. Back in Visual Studio, remember we have the blueprint read-only specifier set for the hitpoints property. I will specify blueprint read-write instead. Save that. Go back to the editor and recompile. Now we have access to that setter. For this example, let's assume that our character cannot have a health of greater than 100. So if we set that to a value that is greater than 100, let's say we pick up a medipack that adds a certain amount to our health, we want to do a check. So I'll place down a branch, and if the new hit points is greater than or equal to 100, then I want to set the hit points to 100. Otherwise, I will simply set the hit points to the new hit points variable. Now we already have that basic functionality implemented in the parents version of the function. So I will simply invoke the parents version of that function. We can always right click on the node, so in this case this event node, and we can select to call the parents version of the function, and we will get this node that we can hook up. I will compile and save and play this, and we still get those values printed out. But if I now use the set hit points node to set the health to 150, for example, that event that we just implemented will get invoked, and because we are trying to set the value to 150, it will do that check, and instead what we are going to do is we are going to set the hit points to 100. We can right click on the event node and select convert event to function. Now we have this blue function node. In the My Blueprint tab under functions, if we double click on that set hit points function in the function section, it opens up a tab with essentially the same functionality that we've implemented before for the event. We can test this and it will still print out 100 twice. As with the other functions, we can now drag in that function from the function section, that is if we need multiple invocations of that, or we can search for that in the context menu. I will test with different arguments, so I will change the new hit points argument to 50 and test again. That should print out 100 and then 50. Remember, we can also double click on the function node itself to get to the definition. We can right click on the set hit points function to convert that back to an event if we want. That is by selecting convert function to event. Now we get that implementation as we had set it up before. I will undo that. Back in Visual Studio, we can specify a category for our functions. As with the U properties, we can specify a subcategory by separating the top category and the subcategory with the vertical bar. For this example, I will specify attributes and then modifiers and getters for the subcategories. Back in the Blueprint editor, in the My Blueprint tab, under Functions, the Attributes category now shows up, and under that we have the modifiers and our getters subcategories. We can also right-click and search for attributes in the graph. Now, depending on our specifiers, we may have access to our variables, and we may also have access to some modifiers. Again, that depends on what the programmer makes available to the blueprints here. For an exercise, implement a damage health function as a blueprint native event. The function accepts values to subtract from the hit points and or the armor health attributes. The function is going to return the modified properties. You may have to think about this one for a bit, play around a bit, and when I come back I will show you my implementation along with a couple of new things. I will declare the damage health function. This is going to return void. This is kind of a silly function, a silly example, but I want to use it to demonstrate a couple of things to you. I will declare the first formal parameter as hit point damage, the second one as new hit points, the third formal parameter as armor damage, the fourth and final parameter will be new armor, which will be a reference to a float. I will copy and paste this U function. The specifiers are blueprint native event, blueprint callable, and then we also have that category. Why do I not specify this as blueprint pure? You may want to take a second to think about that. Remember, I talked about the fact that our blueprint pure functions do not modify the state of its object, but this function is actually going to modify the state of the object. So for that reason, we don't want this function to be blueprint pure. Why do I declare the formal parameters new hit points and new armor as references to floats? Well, if we think about it, how do we get things out of functions? We return a single value or an object from the function, right? Or we can pass by reference if we want to get multiple things out of the function. And with that, we basically have output parameters. As we are familiar with basic C++, a pass by reference will affect the argument that you pass in. Because that reference parameter is simply an alias for the argument that you pass in, we use these references for a different reason, as we need input parameters. That is, we want data to go into the node and also data to come out of the node on the right. I simply prefix these reference parameters with a new, since that is helpful in the blueprint graph, as we'll see a bit later here, but you can use out if that makes sense for you. We set up the formal parameters in this way to get 2 inputs and 2 outputs for the nodal representation of this function. Again, a few things we have to learn and get used to when developing using Unreal Engine. Quick actions and refactoring, and create the definition. Remember, in the definition of the damage health function, we need to provide the underscore implementation suffix as we have done with the set hit points function. So let's do that. Damage health underscore implementation. I will subtract the hit point damage from the hit points and the armor damage from the armor. Now this may be the confusing part. I will assign the hit points to the new hit points and the armor to the new armor. Those references, new hit points and new armor, will be the output values that we will get on your node. Don't worry about it if you did not get that by yourself. The goal with the exercise was just to get you to experiment a bit. I will save those changes so that we can see what we get. Back in the blueprint editor, let's drop down that damage health node. It's blue, not blueprint pure, so we have to hook up those execution pins. I will duplicate the print function since we have the time set to 10 seconds on that one. Print out the new hit points, duplicate the print string node again, and print out the new armor. I will rearrange things a bit. I'm trying to fit all of these things on screen. Let's set the hit point damage to 50 and the armor damage to 35. Compile and save. And if I play now, we will get 100 and 100 printed out, then 50 and then negative 35. Of course, these are from the bottom up, like in a stack, since that is how these print out. Remember that we initialized armor to 0 and health to 100. 100 minus 50 gives 50, and 0 minus 35 gives negative 35, and we get those values printed out. You may have noticed that the get hit points gives us that green node, even if we set that to blueprint callable. So let's do that, save those changes, and recompile, and we can see that we still get a green node. Now one trick I'd like to show you is we can set blueprint pure to false using this syntax right here. I simply assign false to blueprint pure, like so, to force that to not be pure. Again, this is just a trick. Don't do this if the function modifies the state of the target object. I'm showing you this as a bonus just in case you run into some issues. It gives you some flexibility in what you want to do. Also, what do you think will happen when I change these reference parameters to references to const? In the source file, I will comment out these lines since we are assigning to constants now, which will give us an error. We also want to match the parameters. We pass by reference to const. Save those changes. Back in the editor, I will recompile. Note the changes to get hit points and damage health when that recompilation is complete. Get hit points becomes a blue node, and damage health no longer has valid outputs for new hit points and new armor. Those give us errors now, so I'll disconnect those. New hit points and new armor now become inputs to this node. If we drop down a get hit points node, it will give us this blue node with the execution pins. I will undo those changes. That was just a bonus demonstration. Save and recompile. I will hook those nodes back up again, making sure that things work as before. To wrap up, I have this table that we can step through when we are providing specifiers for our functions. We specify the implementation location, so that is blueprint implementable event, blueprint and native event. And then step 2, we specify the blueprint accessibility. Do we want the function to be blueprint pure or blueprint callable? And finally, we can specify a category as with our U properties. And I have an example of a U function macro there with some specifiers, blueprint native event for example, blueprint callable, and then you can also provide a category. Of course, you can swap the specifiers around, you should not get any errors, but this is a common format that you will see. You have the category to the right. That is, the category will be the final specifier in the U function and the U property macros. We just want some consistency with those.